3.2 Reflecting graphs of functions. Okay, so we have two types of reflections of functions. The first is reflecting it in the x-axis, which means you flip it on the x-axis. And the other one would be reflecting in the y-axis, which means you flip it on this one. So we've got some, if this is the point x and y, this is f of x. If this is the reflected point, it is negative x and y. And this one is we've changed our x value so that negative goes inside the brackets. So that is a reflection in the y-axis. The x changes, but it's a reflection in the y-axis. This point over here is a reflection in the x-axis. Our x stays the same, our y changes, and our negative sign would go in front of the function to make our y negative. And this one would be a reflection on both axes, which I don't think we deal with ever, but it could happen. Actually, I don't know. We probably do have it somewhere in here. But it would be negative f, negative x. Okay, so let's do some examples. So we have the point A, B, C, D, and we want to reflect it on the x-axis. So I want you to pause the video and I want you to plot all those points. Okay, it should look like this. Point 1 is in quadrant 1, point 2 is in quadrant 2, point 3 is in quadrant 3, point 4 is in quadrant 4. Okay, we're going to reflect it on the x-axis. So we're going to flip it. So instead of A being up here, it's going to move down here. So what changes is if it's 4 above the line, now it's going to be 4 below the line. And we're going to call this point A prime. And what has changed is our y value is now negative. Our B point is going to move down here. This is my B prime now. And again, only that changes. C prime is going to be up here. Our x doesn't change, our y flips the signs. And our D value is going to be up here, and we're going to call that D prime. And it's at 4 and positive 3 now. And what you should notice is that it is flipped. This is 4, 3, 2, 1. So that is a reflection in the x-axis. Do the same exact thing, and we're going to reflect it on the y-axis now. So I want you to pause the video and write all your points in. Okay, we're going to reflect it in the y-axis, so we're going to reflect on this point. So instead of being over 2 to the right, it's going to be 2 to the left. So my new A prime point is at negative 2 and 4. My new B prime point is going to move over here to positive 3. My new C prime point is going to be right here at positive 2, negative 3. And D will be right here at negative 4, negative 3. So what you should notice is that the first two switch, 2 and 1, and the second two switch. Okay, reflecting images across the y-axis. We have things called lines of symmetry. So this smiley face only has one line of symmetry. It would be down the middle. You can't actually flip it on the x-axis because it's not symmetrical. So to reflect this point, what you're going to do is if you put a dot on this side, you're going to put a dot on this side. So I want you to pause the video, and I want you to finish this drawing off. Okay, so I'm not sure if yours looks as wonderful as mine does, but I mean, not all of us can be artists. Okay, and the next one I want you to write your name and reflect it. So I'm going to write Douglas because that is my name, but you are going to write your own name and make it hard so that it's difficult to do this. Okay, so if I reflect it over here, it's going to look like this. There we go. S's are the hardest part for me. Okay, and then in this quadrant, it'll look like this. Nope. It looks terrible. There we go, that's way better. Apparently it's actually G's that are the hardest for me. And the last quadrant. That doesn't look right. No, it looks right. No. This S is wrong. It should be like that. Did I change it? I don't even know. It's just a normal S. Okay, you get the point. I hope yours looks really fantastic, and I'm sure it does. You're all doing amazing. Okay, so let's do some reflections. We're going to reflect this in the y-axis. Also, just keep this in mind. It's from the first page on the coordinate plane, but I put it again. So let's reflect this on the y-axis. So let's start by doing the domain and range of the original function. These are the same functions, so I'm just going to write it once for both of these. So our left, it goes to the left. -3 is our furthest to the left, and 5 is our furthest to the right. So there's our domain. And our range, it looks like it goes from -2 to 2. Okay, so let's change these up. So we're going to go x, y. So let's plot our points out first. So we have -3 and 1. We have -1 and -2. 3 and -2, and 5 and 2. If we're reflecting it in the y-axis, that means that our x values are going to change. So it's going to be -x and y. So that is a reflection in the y-axis. So our new points are going to be at 3 and 1, 1 and -2, -3 and -2, -5, and 2. Just make them the opposite sign. So we can graph this. So it's going to go over here, this point, and this point. This point's going to go over here. This point's going to go right here, and this point's going to move over here. 3. There we go. So there is our new graph. So the domain, I'm going to write it down here and then I'll erase it. The domain has changed, and it is now going from -5 to +3. So it's the flip of this, but change the signs. And our range is going from, it's not changing because we didn't do anything to the y's. Alright, there's our domain and range. Okay, we're going to do the same thing down here, but we're going to do it to the on the x-axis. Okay, so it's going to be x, and our y is going to change. So it's going to be at -3 and -1, -1 and +2, 3 and +2, and 5 and -2. Alright, so this one's going to flip. We're just going to flip all those points. So it looks like that. Alright, domain doesn't change. So it's still negative 3 less than x less than or equal to 5. And our range is going to flip. So it's going from negative to, it flips, but we're still going from negative 2 to 2. So actually it doesn't really change. Okay, the graph of y equals 1 over negative 2x squared subtract 0.5 was reflected in the x-axis and on the y-axis. What is an equation for each of these images? Okay, so we're going to do it twice. We're going to do it once where we're reflected on the x-axis and once where we're reflected on the y-axis. So let's reflect it on the y-axis first. So if I reflect it on the y-axis, oops, I got it backwards. If I reflect it on the y-axis, what's changing is our x values. So we put the negative sign there because our x values are the ones that are changing. So when I plug it into the equation, I'm going to put a negative x squared in. And then I'm going to simplify. Oops. So negative x squared is still x squared. So if you look at this, the equation has not changed. And if you think about it, if I was to rotate or flip this on the y-axis, it would still look like this. It wouldn't change at all, right? Because it's symmetrical on both sides. So that's good that our equation didn't change. Okay, let's reflect it on the x-axis. So when I reflect it on the x-axis, the thing that changes is the y's. So the negative goes in front of the equation. So we go y equals negative 1 over negative 2x squared minus 0.5. And then we can distribute that negative in. So it's now 1 over 2x squared plus 0.5. And our graph's going to look like this. It's going to be above the line now. Alright, here's the function y equals the square root of x minus 3. Fill in a table of values and show the reflections. And it has each of the types of reflections. So let's make a table of values. So we've got the point 0 and negative 3. We've got the point that looks like a good point, 1 and negative 2. And we've got the point, like right there, 4 and negative 1. We'll use those as our lattice points. Okay, so if we're going, let's do this one first. We have y equals negative f of x. Because it is in front of the function, that means that my y value is changing. Oops, and I didn't even write that. So this one is a reflection. Because the y value is changing, it is a reflection on the x-axis. Okay, so the new points would be 0 and 3, 1 and 2, 4 and 1. So this graph's going to look like this. 3, 2, 1. Oops, I meant to put this down here. 3, 2, 1. And I do not want that. Good. Okay, so this is negative f of x. Let's do y equals f of negative x. So because it's with the x, our x value is the one that is flipping, and because our x is the one that is changing, it's a reflection on the y-axis. So 0 doesn't change. Now our point's going to be at negative 1 and 2 and negative 4 and 1. So this point is going to look like this. Oh, I did it again. There's our graph. So this is f of negative x. And the last one is as if they were to both change. It's a reflection in the x and the y axis. So it would be negative x, negative y. So we have 0 and 3, 1 and 2, negative 1 and 2, and negative 4 and 1. So this point is going to go 0 and 3, negative 1 and 2, negative 4 and 1. So there's our graph of negative f of negative x. And that is reflections. And that's it. Okay, moving on to the next transformation. Bye!